Good morning, children. Today we are going to do chapter 5b of your book, that is Selina's Concise Chemistry. Today we will cover this units, that is relative atomic mass, relative molecular mass and mole concept. This is a very important unit of this chapter. On this basis of this basics, you have to complete the remaining 2 units. So first we'll know what is relative atomic mass. Shortly it can be called as RAM or atomic weight. What is this? It is the number of times one atom of the element is heavier than 1/12 times of the mass of an atom of carbon 12. Now what is this carbon 12? Carbon 12 is the isotope which is having mass number 12. So we can say relative atomic mass equal to mass of one atom of element divided by 1/12 the mass of one C12 atom. Now what is atomic mass unit? This is known to you. This AMU generally defined as 1/12 the mass of carbon atom C12. Now these are the definitions, and whatever you have to do actually in real sense, like calculations, that you have to do whatever you have done till now, the same way. Now another concept is fractional atomic masses. It is observed that most of the atomic masses are not whole numbers. Why? Because most natural elements are a mixture of constant composition containing 2 or more isotopes. Now the RAM, that is relative atomic mass of any element, is the weighted average of the RAMs of its natural isotope. Now you have seen the example many a times. It is a very known example, so I am not going to describe this. You can see from the calculation. Now next is your RMM, or relative molecular mass or molecular weight. The definition is same as that of the RAM, only here in the numerator you have mass of one molecule of a substance. So how do you find out this relative molecular mass? The same way you did till now since your class 7th, by adding together the RAMs or atomic weights of all the atoms present in the molecule. Example given for CuSO4.5H2O. Now here this relative atomic mass is given, but it is not the fact that every time it will be given. You will find soon in different numericals. So you can find out. Then go for these 2 scales. We have done everything till now on the basis of carbon 12 scale. There is another scale which is hydrogen scale, which was used earlier, but not now. It is only used the carbon scale. Now this hydrogen scale will be used when you will be doing the relative vapor density. Now what is this hydrogen scale? It is the number of times an atom of an element or compound is heavier than an atom of hydrogen. And carbon scale, the same, the average relative mass of an atom of an element or compound as compared to the mass of an atom of carbon taken as 12. So these 2 are the formulas. Very easy one, but very important. Then you have gram atomic mass. Atomic mass, you know that when expressed in grams is called gram atomic mass. Now atomic mass of oxygen, atomic mass. I have shown O2 as a symbol over here for oxygen. It's not O2 as a molecule. So atomic mass of oxygen is 16 AMU. So gram atomic mass of oxygen will be 16 gram. So 1 gram atom is equal to gram atomic mass. So 16 gram of O2 is equal to gram atomic mass of O2, that is 1 gram atom of oxygen. Now here this O2 is taken for oxygen, not for oxygen molecule. Similarly, 23 gram of sodium is equal to 1 gram atom of sodium. Now you consider the gram molecular mass, same molecular mass of a substance expressed in grams. So gram molecular mass is equal to gram molecule. Now what is the molecular mass of water? That is 18 AMU, that is equal to gram molecular mass. So how do you say? Gram molecular mass, or you will say molecular mass of water is 18 gram. Similarly, for ammonia, gram molecular mass is 17 gram, which is equal to molecular weight or molecular mass. This is very important, mole concept, because the next 2 units will be based on this only. Now, it is not possible for us to find the mass of an atom, molecule or an ion, etc. So, we have to have a collection of 6.022 into 10 to the power 23 elementary particles, which is called a mole. Like we know 1 dozen is equal to 12 objects, 1 gross is equal to 144 objects. Similarly, 1 mole is equal to 6.022 into 10 to the power 23 particles. This you have to learn. You have to remember. So these particles are atoms, molecules or ions. So now what is the definition of a mole? Mole is the amount of pure substance containing the same number of chemical units as there are atoms in exactly 12 grams of C12 or carbon 12. Now what is Avogadro number? Defined as the number of atoms present in 12 gram, that is gram atomic mass of carbon 12 isotope, that is 6.022 into 10 to the power 23, denoted by N or Na. So mole of atoms, 1 mole of oxygen atoms contains 6.022 into 10 to the power 23 atoms of oxygen and weighs 16 gram. What is mole of molecules? 1 mole of oxygen molecules contain 6.022 into 10 to the power 23 molecules of oxygen and weighs 32 gram. Now this is the beauty. If you go for atoms, this will be atoms. If you go for molecules, this number will be for molecules, similar for ions. Now what is molar volume? Molar volume is 1 mole of any gaseous molecule occupies 22.4 dm³ or liter or 22,400 cc or milliliter at STP. This is known to you. This volume is known as molar volume, and this is only applicable for gases. Others are applicable for all, solid, liquid, everything. So this is the summary. Just go through this 1 gram molecular mass is equal to 1 mole is equal to 6.02, sometimes it is 6.023, sometimes it is 6.022 into 10 to the power 23 molecules and 22.4 liter at STP if the substance is a gas. So all the conversions and everything is given over here. This you can see, you have sulfur dioxide, here you have 1s, 2 oxygen. So number of atoms will be S this much, 2 oxygen, so 2 into Avogadro number. Similar over here, similar over ammonia. In hydrogen, 3 hydrogens are there, so 3 into Avogadro number. Chlorine, 2 chlorines are there, so 2 into Avogadro number. Now I'll do the examples. Example 2 of page number 78. Number of atoms in 1 mole or 1 gram atom of an element is 6 into 10 to the power 23. So calculate number of molecules in 14 gram of nitrogen gas, total number of atoms in 18 gram of water, and number of chloride ions in this. So you find out mass of 1 mole of nitrogen. So 28 gram contains 6 into 10 to the power 23 molecules. Now this is given. So you have to take this. You cannot take whatever is known to you, that is 6.022 into 10 to the power 23. So find out how much is for 14 gram nitrogen. See. So next is mass of 1 mole of water is 18 gram. So 18 gram contains Avogadro number. Now water contains 2 hydrogen and 1 oxygen. So total 3 atoms. So you have how many atoms? 3 into 6 into 10 to the power 23 atoms. That is, it will come as 18 into 10 to the power 23. Then mass of 1 mole of anhydrous CaCl2. You will get it as 111. How many chlorine? 2 chlorine. How many calcium? 2 calcium. Now they have asked the question as number of chloride ions. So we have to only consider the chloride ions. So how many? 2 into, why 2? Because of 2 chloride ions, into 6 into 10 to the power 20. Same like calculate the mass of one atom of oxygen and one molecule of oxygen. For this you take 16 gram of atomic oxygen contains these atoms. So 16 grams weigh 16 gram. Sorry, 6.022 into 10 to the power 23. Now here Avogadro number is not given, so you take whatever you know. So keep this term which is to be determined on the right side as discussed in the class. I have already told whatever you have to find out, that term to be taken on the right side. If you have to find out atoms, take atoms on right side. If you have to find out the weight, you take weight on the right side. So similarly you can get. This is the second question. For the next portion, follow the second video.